Good evening, guys. So today we'll be finishing off pH, right? The last part we have to do is carbonate acid titrations, right? So we'll finish it off today, right? So that's the difficult part I feel like in pH because uh, the reason is it's a little bit complex, right? So we'll discuss it deeply, right? And we'll do question also, so you'll understand it. Okay. So focus very carefully, right? Because this is a little bit of a difficult section, right? Now, normally we have talked about monoacidic bases and monobasic acids, right? Which means acids which releases 1H plus ions to the solution and bases which accepts 1H plus to the solution, right? So regarding those things we have spoken, right? But here the speciality is, now if you take carbonate acid titration, normally carbonate will be accepting 2H pluses from the solution, right? So therefore you will have 2 Kb values, and also carbonic acid H2CO3 also can release 2H plus ions to the solution. Therefore you will have 2 Ka values for that, right? So there are 2 Ka values, 2 Kb values, and also when doing the titration you'll be having two equivalence points. You'll be having two equivalence points, right? So that is the main difference in these type of titrations, right? So we'll look into it slowly, right? So before going into the titration part, I have to tell you some basic things, right? So you just have to remember this, right? First one is, if you put carbonic acid in water, right? If you put carbonic acid in water, what will happen? It will be ionizing, right? It will be ionizing because any acids will be ionizing. So how will it ionize? It will be, no, carbonic acid is acid, right? So therefore it will be donating H plus ions to the solution, right? So if it donates, what will you get? You'll be getting bicarbonate and H3O plus, right? That is the product you're gonna get. Now also if you see, this bicarbonate can further ionize, right? This bicarbonate can further ionize because what is the reason? It is having a H, right? Hydrogen is present. Therefore, it can release that H plus ion to the solution, right? So this will be further ionizing. So how will it further ionize? Bicarbonate aqueous, right? When you ionize in water, it's gonna form an equilibrium and it will form carbonate, right? Carbonate and H3O plus, right? H3O plus, right? Now I said bicarbonate, in bicarbonate there are two Ka values, right? There are two Ka values, right? So generally, right, that is a general, there is no particular reason for that, but generally we say the Ka of the first reaction as Ka1, right? That is how it is provided, Ka1, we call it as Ka1, right? There is no particular reason for that, there is a general way, right? And for the second ionization we say it as the equilibrium constant as Ka2, right? So we give the equilibrium constant as Ka2, right? So that you have to remember. Also, if you put carbonate into a solution, carbonate. Now you all can see carbonate is a conjugate base, right? So carbonate can act as a base, right? So it can accept H plus, right? According to Bronsted-Lowry, a base is a substance which can accept H plus from a solution, right? So carbonate will be accepting H plus from water. So if it accepts H plus from water, it will be forming what? Bicarbonate and OH minus, right? Because water will be losing one H plus, so it will be forming OH minus, right? Now this can further accept on H plus, right? Because it can form carbonic acid. So what will happen? This will be further accepting another H plus from the water. So what will happen if it accepts? It will be forming carbonic acid, right? So it will be forming carbonic acids. Bicarbonate and water, carbonic acid, H2CO3, that is also aqueous, plus OH minus, right? Now here also you can see this is a base, this is a base, right? So there are two Kb values for this. So generally we provide the first reaction as Kb1, right? There is no particular reason, right? Just we say this as Kb1 and we say this as Kb2. That's how it's named, right? Okay, right? So you have to remember this, okay? Which is K1, which is Ka2, and which is Kb1, and which is Kb2. You have to remember this, right? And then we know that Ka into Kb is equal to Kw, right? So we know Ka into Kb is equal to Kw, right? But here you all can see two Ka values and two Kb values, right? So which one is valid? You have to check that. Now if you multiply Ka1 by Kb1, if you multiply Ka1 by Kb1, you won't be getting Kw, right? You won't be getting Kw, right? If you all want, you all can multiply and check. But if you multiply Ka1 by Kb2, right? If you multiply Ka1 by Kb2, then you will be getting Kw, right? And also if you multiply Ka2 by Kb1, you'll be getting Kw also, right? So you'll have to remember these two equations because that is very important when doing the titration question, right? So Ka1 into Kb2 is equal to Kw, and Ka2 into Kb1 is equal to Kw. That you have to remember, right? So again, I'll brief it quickly. So carbonic acid is a acid which can donate two H plus ions to the solution, right? So the donation of H plus ions takes place in two steps, right? First H plus will be donated in the first step, and the second H plus will be donated in the second step, right? So if you put carbonic into water, it will be forming bicarbonate and H3O plus, right? Here what happens is carbonic acid donates one H plus to the water, right? So water will be accepting it and it will be forming H3O plus. Now this bicarbonate will be further ionizing in water and will be forming carbonate and H3O plus, right? So you can see there are two acids here ionizing, right? So we had to give Ka values for that, right? So generally we provide the first reaction, that is the carbonic acid ionization, we say it as Ka1, and bicarbonate ionization we say it as Kb2, right? And same way carbonate can accept two H pluses, right? So this will be happening in two different steps, right? First one it will be accepting one H plus, and the second step it will be accepting the next H plus, right? So it will be happening in two steps, and you will be naming these Kb values as the carbonate reaction will be naming as Kb1 and bicarbonate reaction Kb2, right? Now we know that Ka into Kb is equal to Kw, right? That everyone knows. So by using these reactions, you can build the relationship, that is Ka1 into Kb2 is equal to Kw and Ka2 into Kb1 is equal to Kw, right? So Ka1 into Kb2 is not Ka1 into Kb1 is not equal to Kw, right? If you all want, you all can multiply and see, you won't be getting Kw, right? You won't be getting Kw, right? So this is the valid, right? So if you want Ka1 into Kb2, see, will be H3O plus OH minus will be remaining. Bicarbonate will be cancelling off. Carbonic will be cancelling off. Water will be cancelling off, right? So if you multiply Kb2 by Ka1, you are getting Kw. Same way, if you multiply Ka2 by Kb1 also, you'll be getting Kw, right? So soon copy down this. We'll move into the titration part. Right. I hope you all copied it. Now we will move into the titration part. That is the important part, right? So you all will understand the importance of this when you are doing the titration questions, right? So now I have just given the intro. So we'll go into the question and then you will see the importance of this Ka, Kb and the relationship, right? Now carbonate acid titration can be done in two ways, right? So normally you all know that there is two instruments mainly we use. One is the titration flask, and other one is the burette, right? Right. Now that is the titration flask and this is the burette, right? So the major type of titration they can ask is when the carbonate is placed in the titration flask, right? And H plus, that is mainly we'll be titrating with it HCl, right? So any acid, right? This is one way that you can do the titration. And the next way, what you how can you do? You can place the H plus solution in the titration flask and carbonate in the burette, right? That is also possible, right? This is also possible, right? So this is the burette. Here you'll be keeping the carbonate, and here you'll be keeping the H plus in the solution, right? So this is method one. Like that also you can titrate, and this is method two, right? So main questions regarding carbonate will be in this method. Method one, that is carbonate is in the titration plus and burette is in the H plus is in the burette, right? So this type of titration is the mainly asked titration in carbonic acid, right? and this is the complex part also, right? This is simple, this is like normal titrations, right? So after discussing this, I'll come into this, right? So first of all, we are going with this titration, that is carbonate is placed in the titration flask and H plus is placed in the burette, right? Now, what are the normal questions they ask? They will give this titration. So normally, what they provide is they will provide the concentration of carbonate, volume of carbonate, and concentration of acid, right? That is H plus. H plus means any acid, right? So that is the normal way, right? And first, what they will ask is they will ask the equivalence points. Now, in these type of titration, what will happen is there are two equivalence points, right? There are two equivalence points, right? And they'll be asking what is the equivalence point. But they'll ask the first equivalence point, they'll ask the second equivalence point, and they'll ask the pH before the addition of H plus, and they'll ask the pH at equivalence point, first equivalence point, and the pH at second equivalence point, right? That is the general type of questions they ask, right? So first of all, if they ask the pH at the titration flask initially, right? How can you find the pH? Now initially, right? If they ask the pH before addition of H plus, right? If they ask, no, normally they ask is this, right? What is the pH in the titration flask before the addition of H plus? And how can you find it? Now, before the addition of H plus, only carbonate is present in the solution, right? Only carbonate is present. So what will happen? Carbonate will be ionizing, right? Carbonate will be ionizing. So carbonate with the water liquid, right? So physical states is a must in physical chemistry, right? You have to put the physical states because otherwise you will be losing marks. So carbonate in water, what will happen? It will be ionizing and it will be forming bicarbonate and OH minus, right? So you all know before the addition of H plus, this is the equilibrium that is present in the titration flask, right? So they will provide the initial concentration of carbonate and the volume of carbonate. So if you know the initial concentration, right, you can find the concentration of OH minus using the Oswald dilution theory. That is the normal way we do, right? Normally weak bases we do same thing you have to do here, right? So they will give the kb1 value, so you have to find the oh minus, right? So if you find oh minus, you can find the poh, and using that you can find the pH, right? So just the idea I'm giving, so we will do the question later, right? So if they ask pH before the addition of H plus, this is the equilibrium that is present in the titration flask, and using this you can find the concentration of oh minus, and using that you can find poh, and using that you can find pH, right? And next they will ask is what is the first equivalence point. Now what's happening? To reach the first equilibrium, you will be adding H plus through the burette. You will be adding H plus, right? Now, what will happen? Carbonate will be present in the solution. This is at first equivalence point. I am saying the reaction, right? First equivalence point reaction. First equivalence point reaction. Now, at first equivalent points, what happens is you will be adding H plus from through the burette. You will be adding H plus through the burette. So the added H plus will be reacting with the carbonate present in the titration flask, and what will it form? It will be forming bicarbonate, right? So this is a complete reaction, right? This is a complete reaction because when acid and bases react means complete reaction, right? So at first equivalence point, what happens is all of the carbonate present in the titration flask will be converted to bicarbonate, right? The moment where the volume of H plus needed to convert the carbonate into bicarbonate is known as the equivalence point. That is the first equivalence point, right? So at first equivalence point, this is the reaction that happens, right? All of the carbonate will be converted to bicarbonate, right? And then they will ask what is the pH at first equivalence point. pH at first equivalence point. Now how can you find that? Now first equivalence point, you know there is no carbonate available, right? Because all of the carbonate is converted to bicarbonate, right? So bicarbonate will be determining the pH at the first equivalence point, right? So bicarbonate will be, what will it do? It will be ionizing in water. So how will it ionize? Bicarbonate will be, so write the physical states, okay? So I might miss, right? So you all definitely have to write because marks is provided for physical states. That's it. Right? Aqueous. So what will happen? Bicarbonate, and after the end of the first equivalence point, you'll be having only bicarbonate in the solution, right? Now this bicarbonate will be ionizing in water, and it will be forming what? It will be forming carbonic acid, right? So you all have to remember carbonic acid. And what will it form? OH minus, right? because bicarbonate will be accepting one H plus from the water and form carbonic acid, and remaining from water is OH minus, right? So this is the equilibrium formed by bicarbonate at the first equivalence point, right? So this is Kb2, right? This is the value. This reaction is regarding Kb2, right? So if you will know, if you have to find the value of Kb2, and they will you can find the concentration of bicarbonate also. So using the Oswald dilution theory, you can find the concentration of OH minus, right? And if you know the concentration of OH minus, you can find POH, right? And if you know POH, you can find pH, right? So that's how you will be finding the pH at equivalent first equivalence point, right? Now next question they will ask is, what is the second equivalence point, right? Now second equivalence point, what happens? Second equivalence point. Now only bicarbonate is remaining in the solution, right? Because all of the carbonate have been converted to bicarbonate in the first equivalence point. Now in the second equivalence point, what will happen is, right, this bicarbonate, right, the formed bicarbonate will be further. Now you at the second equivalence point, you'll be further adding H plus, right? So the bicarbonate will be reacting with the added H plus, right? And what will it form? It will be forming carbonic acid. It will be forming carbonic acid, right? Right. Now second equals point, what? Bicarbonate will be reacting with H plus and forming carbonic acid, right? So how can you find the pH at second equals point? Right, I'm having lack of space. I hope y'all can see this. Can all see this? Wait. Yes, it is visible. So how can you find the pH at second equals point? pH at second equals point. Carbonic acid will be ionizing in water and it will be forming bicarbonate and OH minus, right? H3O plus, right? Because carbonic acid will be releasing H plus to the solution. So H plus will be accepted by water and it will form H3O plus. Bicarbonate will be forming, so carbonic acid will be forming bicarbonate, right? So this is the equilibrium constant for Ka, right? Ka1. This is regarding Ka1. So they will provide the Ka1, and you will come to know about the concentration of H2CO3, right? You can find through this, and from that you can find the concentration of H3O plus, and from that you can find the pH, right? So this is the general idea, right? Normally what they ask, what is the pH before the addition of H plus, and they will ask what is the first equivalence point, right? Then they will ask what is the pH at first equivalence point, and they will ask what is the second equivalence point, and they will ask what is the pH at second equivalence point, right? So these are the generally the reactions happening at the particular steps, right? These are the reactions that is happening in the particular steps, right? So you all must know this, right? Mainly many students confuse with this reaction, because they know at the first equivalence point bicarbonate is present, right? And they will be they know that it will be ionizing, right? The bicarbonate will be ionizing in water, and the doubt comes here: what is the product? Is it carbonic acid or is it carbonate, right? Because will it donate H plus or will it accept H plus? There is a doubt, right? Many students will be having this doubt, right? So now you all might know, right? When you're doing the question on your own, right, you'll be thinking what will be the product? Is it carbonate or carbonic acid, right? So you have to remember the product is carbonic acid, right? This is very important because many students confuse with this, right? Some students they'll be putting bicarbonate as a product, right? So you have to be careful with that, right? Uh, Other things also you all can, if you understand this, you all can get the equilibrium. But here the product you have to be careful, that is carbonic acid, right? Right. Then this copy this down. These are the reactions at each steps. So copy this down. Right. I have one more thing to explain also. I'll explain that also, right? Now, if you take indicators, What are the indicators you have? Mainly regarding this, we will be having phenolphthalein and methyl orange, right? Phenolphthalein and methyl orange, right? So they will be providing color changes, right? So according to the pH range, they will be providing the relevant color changes, right? Now if you take mainly, if OH minus, right? So I'll write in the end, OH minus, carbonate, bicarbonate, bicarbonate, and finally H plus, right? Assume this is phenolphthalein, pH, phenolphthalein, phenolphthalein. Another one we are using is methyl orange, right? Methyl orange, methyl orange, right? Now phenolphthalein will be colorless in acidic medium and it will be pink color in basic medium, right? So if you take in OH minus, when the titration flask contains OH minus, the phenolphthalein will show what color? Be forming pink color, right? Because this is a basic medium. And in carbonate also, if carbonate is present in the surrounding of phenolphthalein, it will be showing pink color, right? You can say pink or red color, anything is fine, right? So something close to that. So, but when bicarbonate is present in the phenolphthalein, right? If you add phenolphthalein to bicarbonate solution, it will be forming colorless, right? It will be forming colorless, right? It considers this as a acidic medium, right? And in H plus, definitely it's going to form colorless, right? But methyl orange, if you take, it shows orange color in basic medium and a red color in acidic medium, right? So methyl orange, if you put it in OH minus, what is the color it's going to form? It's going to form orange color, right? Orange, or it might be yellow also, right? So that is relative to each person, right? Orange, yellow, something closer to that, right? So if you put in carbonate also, that is same color is going to show, that is orange and yellow, right? And if you put it in bicarbonate also, it's going to form the same color, that is orange or yellow. And when you put it in H plus solution, it's going to give a red color change, right? You can see a red color change, right? Okay. Now, what is the suitable indicator that can use for first equivalence point? Look at this and tell me what is the suitable indicator that you can use. Now, first equivalence point, what is happening? Carbonate is converting to bicarbonate, right? So you have to select an indicator which shows the which shows one color at carbonate, and when bicarbonate is formed, it must show another color, right? That is the indicator, right? So it must show a color change, right? So carbonate, at when carbonate is present, it must be at one color, and when bicarbonate is present, it must change into another color, right? Now if you look at methyl orange, you all can see at carbonate also it provides orange yellow color, and at bicarbonate also it provides orange yellow color, right? So at bicarbonate and carbonate, it shows the same color. So you can't use methyl orange, right? Because it's gonna show the same color. Now, what about phenolphthalein? Phenolphthalein, you can see it's when it's carbonate, it's showing pink color, and it forms when it forms bicarbonate, it's showing colorless, right? So you can use phenolphthalein to find the first equivalence point, right? Because when carbonate is present, it will be showing pink color, and when bicarbonate forms, it will be becoming colorless, right? So you can use phenolphthalein to find the first equivalence point. So you have to remember this, right? Phenolphthalein indicator can be used to find the first equivalence point, right? Now, what indicator can you use to find the second equivalence point? So second equivalence point, what is happening? Bicarbonate is converting to carbonic acid, right? So the indicator must show a different color at bicarbonate, and it must show a different color when carbonic acid is formed, right? Now look at phenolphthalein. At when bicarbonate present also, it becomes colorless, and when H plus, right, that is carbonic, right? Carbonic is acid, right? So it will be releasing H plus, right? So when H plus is formed, it also shows a colorless solution, right? So you all can differentiate it between the two solutions, because at both instances it's showing colorless. But when you look at methyl orange, you can see it shows orange color when bicarbonate is present, and it shows red color when an acid is present, right? So here the same thing happens. Bicarbonate is converting to carbonic, right? So here it shows orange color. If you use methyl orange, it'll be showing yellow orange color here, and it'll be showing red color here, right? So the most suitable indicator to use at second equivalence point is methyl orange, right? Methyl orange can be used at the second equivalence point, right? So they can ask, right, what is the suitable indicator that you can use? Methyl orange, right? So remember that also, right? Right, then copy this down, we'll go into the question. Copy this down. Right. I hope you all have done it. Right. Now we will move into a question. Right. So we will understand it more clearly. This is the basic idea that you must have. Right. Now the question is, consider a titration of 25 centimeter cube of 0.1 mole dm minus 3 sodium carbonate, right? So sodium carbonate means it will be ionizing, right? It will be forming carbonate, right? So I think 25 centimeter cube of carbonate has been used. It seems 25 centimeter cube has been used, and the concentration of carbonate solution they have given as zero point 0.1 mole dm minus 3. They have given us zero point 0.1 mole dm minus 3. That is the concentration of carbonate, right? And they have titrated with an acid, that is HCl, and that is a zero point 0.1 mole dm minus 3. The concentration of the acid is zero point 0.1 mole dm minus 3, right? Okay. And they have given Ka1 and Ka2, right? So Ka1 is given as Ka1 is given as 4.3 into 10 to the power minus 7, right? 4.3 into 10 to the power minus 7, and Ka2 is given as 4.7 into 10 to the power minus 11. 4.7 into 10 to the power minus 11, right? So they have the units of mole dm minus 3, and here also the unit is mole dm minus 3, right? Now what are they asking? They're asking what is the first equivalence point, right? They're asking the first equivalence point, right? So first equivalence point, what happens? H plus will be reacting with carbonate and bicarbonate will be formed, right? That is happening at the first equivalence point, right? So I'll write the reaction. H plus will be reacting with bicarbonate, and what will it form? Sorry, it will be reacting with carbonate, and what will it form? It will be forming bicarbonate, right? Bicarbonate, right? Write the physical states: aqueous, 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 right? So what is the initial moles of carbonate that is present? You all know the concentration, you all know the volume, right? So you all can multiply C into V. Then you will get the moles, right? So what is the initial moles of carbonate? zero point 0.1 into 25. So to convert centimeter cube into meter cube, I'll be dividing it by 1000, right? Okay. Now this much initially carbonate is present, right? Now to react with the carbonate, now ratio is 1 is to 1, right? The ratio is 1 is to 1. What is the moles of H plus you need? You need the same moles of H plus. What is the moles of H plus? 0.1 into 25 over 1000. That is the moles of H plus needed to react completely with the carbonate, right? So the moles of H plus you need is zero point 0.1 into 25 over 1000, right? Because you all know initial moles of carbonate is this value, right? So you need the exact amount of H plus to react with it, right? So the moles of H plus you need is zero point 0.1 into 25 over 1000. So they're asking what is first equivalence point? What do you mean? The moles of H, the volume of H plus needed to react completely with carbonate, right? So the moles of H plus you need is this, right? They're asking the volume of H plus. So how can you write? N equals Cv, right? You all know N, that is zero point 0.1 into 25. So I can write this as zero point 0.1 into 25 is 2.5, and 10 to the power minus 3. That is the moles of H plus, right? What is the concentration of H plus? Zero point 0.1. And what is the volume? That is the equivalence point, right? So if I multiply it by volume, I will be getting the volume in decimeter cube, right? So to get the answer in centimeter cube, I will divide it by 1000, right? So division means I am multiplying it by 10 to the power minus 3. That is same as division by 1000, right? So 10 to the power minus 3, 10 to the power minus 3 will be cutting off. So V will be equal to 25 centimeter cube, right? So this is the first equivalence point, that is 25 centimeter cube, right? So I'll note it down here because I need V equivalence point first, right? What is it? It is 25 centimeter cube. So did you all get it? Did you all get it? How to find the first equivalence point? You have to find the moles of carbonate that is present in the initially, right? So at first equivalence point, what happens? All the carbonate is converted to bicarbonate, right? So carbonate, you have to find the moles of carbonate, right? And then you have to find the moles of H plus that is needed to react with the carbonate present, right? So that is same as the carbonate moles because the ratio is 1:1, right? Then what you have to do? You have to find the volume of H plus needed. That is the equivalence point one, right? So how can you find the volume? Moles equals to concentration into volume. You can put that formula and you can find the first equivalence point, right? So the first equivalence point is 25 centimeter cube. And next, what are they asking? What is the second equivalence point? Now, second equivalence point, what happens? Second equivalence point, what is happening? Now, bicarbonate is formed in the first equivalence point. Second equivalence point, what will happen? These bicarbonate will be reacting again with the H plus added, right? It will be reacting again with the H plus added. And what will it form? It will be forming carbonic acid, right? H2CO3, right? H2CO3. Now, what is the moles of carbonate that is bicarbonate that is present? Now, initially, what we did, we added H plus to carbonate, right? That is at the first equivalence point, we added H plus to carbonate, and you got bicarbonate, right? And the initial moles of carbonate was uh, 2.5 into 10 to the minus 3 mole, right? This is the first equivalence point scenario I'm talking about, right? So initially there was 2.5 into 10 to the minus 3 moles, right? And you added the same moles of H plus to the solution also, right? So there was no bicarbonate present initially. Now what will happen? Now this is like the initial moles, right? Now what will happen? It will be reacting, right? Now who's the limiting reagent? Now both are having equal amounts, right? So both is going to react in equal manner. So 2.5 into 10 to the minus 3 is going to react. And here also 2.5 into 10 to the minus 3 moles of H plus is going to react, right? And what will happen? Here 2.5 into 10 to the power minus 3 moles of bicarbonate will be forming, right? So at the final, right, after the reaction is complete, the final moles of bicarbonate will be 0, H plus will be 0, and sorry, the final moles of carbonate will be 0, H plus will be 0, and the final moles of bicarbonate will be 2.5 into 10 to the power minus 3 moles, right? So this is the scenario at the first equivalence point. So initially you had 2.5 into 10 to the power minus 3 moles of carbonate, right? And you added equal amount of H plus, that is what you are doing in first equivalence point. Then what will happen? Both will be reacting completely, right? So finally you'll be having 0 moles and you'll be having 2.5 into 10 to the power minus 3 moles of bicarbonate, right? So when you are looking for the second equivalence point, initial itself you'll be having how much? 2.5 into 10 to the power minus 3 moles of bicarbonate, right? So what do you mean by second equivalence point? H plus needed to react completely with this bicarbonate, right? So what is the volume you need for that? That is the second equivalence point. Now how can you find that? Now if you are having 2.5 in 10 to the power minus 3 moles of bicarbonate, how many moles of H plus you need to react with this bicarbonate? Same equal amount of moles of H plus is needed, right? Because the ratio is 1:1. Therefore, equal amount of H plus is needed. So what is the moles of H plus that is needed for you? 2.5 into 10 to the power minus 3 moles, right? And what is the volume of H plus needed? You can put N equals Cv. So N is equal to 2.5 into 10 to the power minus 3 moles. What is the concentration of H plus? 0.1. And what is the volume? So if I multiply by volume, I'll be getting decimeter cube, right? In decimeter cube, I'll be getting. So to get in centimeter cube, I'll divide it by 1000 also. So volume I'll be getting is 25 centimeter cube, right? Now what does this mean? You need another 25 centimeter cube of H plus to react with the bicarbonate, right? So first 25 centimeter cube is to react convert the carbonate into bicarbonate, and the second 25 centimeter cube is to convert the bicarbonate into carbonic acid, right? So what is the second equivalence point? So here you'll be having a twist, right? It's not 25, it's gonna be you need 25 and initially you added 25. So the second equivalence is gonna be 25 centimeter cube plus another 25 centimeter cube, right? That is 50 centimeter cube, right? The second equivalence point is 50 centimeter cube. You have to keep that in mind, right? So this is 25 centimeter cube HCl is needed to convert this to this, right? So initially you have added 25 centimeter cube to convert carbonate to bicarbonate. So the second equivalence point is 25 plus 25, that is this 25 plus this 25, that is going to be 50 centimeter cube. So keep that in mind. equivalence point 2 is equal to the volume plus the first equivalence point volume, right? 50 centimeter cube. So we have found the equivalence points, right? Now what are they asking? What is the initial pH in the titration flask, right? They're asking the initial pH, that is before the addition of H plus, right? Now initial pH I gave the reaction also, right? So in the theory I have given the reaction also. So what is happening before the addition of H plus? Only carbonate is present. Only carbonate is present, right? So what will happen? It will be ionizing in water, and what will it form? It will be forming bicarbonate, right? It will be forming bicarbonate and OH minus, right? OH minus, right? Now how can you find the pH? You had to write the same three values, right? Initial concentration, that is we wrote in Kp also, we wrote in Kc also, Ksp also we wrote, right? Now we are writing in Ka. Initial concentration, change in concentration, C means change, and finally you had to write equilibrium concentration, right? Equilibrium concentration. What is the initial concentration of carbonate? 0.1 mole dm minus 3, right? So initially, that is before the addition of H plus, right? We are talking about before the addition of H plus, right? There is no carbonate before the addition of H plus initially. Now what will happen? X amount will be breaking, X amount will be forming, X amount will be forming, right? At equilibrium, what you will have? You will have zero point 0.1 minus X. Here will be having X, and here will be having X concentration of H plus, right? Now what you can do? You can put the KB1. This is KB1, right? So I have given the reaction. This is KB1, right? But you don't have KB1. Then how can you find? You have to first of all find KB1, right? So Ka1, Ka2. Now this is Kb1, right? So I'll write the equilibrium constant first. Kb1 is equal to what? Product's concentration over reactant concentration. What is the product concentration? Bicarbonate into OH minus aqueous over reactant concentration. What is the reactant concentration? Carbonate, right? We don't put water. What is the reason for that? We don't include water because water's concentration is constant, and that will be coming automatically into the Kb value, right? So normally in Kb, Ka, Kb, Kp, Kc, Ksp, everything we don't put concentrations of pure liquids, pure solids, right? We don't include them in the equilibrium constant reaction, right? Now this is the expression, right? Now by looking at this, you can say at equilibrium carbonate and OH minus concentration is same, right? You can tell that, right? So at equilibrium, what you can say, bicarbonate concentration is equal to OH minus concentration, right? See, it is equal because X and X, right? So what you can say, Kb1 is equal to concentration of bicarbonate. I can say it as OH minus, so I can write it as OH minus squared, right? Concentration of OH minus squared. How I wrote? I'll be now this is same, right? So I can put instead of bicarbonate, I can put OH minus here, right? So OH minus into OH minus is gonna be OH minus squared over carbonate concentration, right? Now before going everything, before going into the question, you have to find Kb1. So how can you find Kb1? So I said KB, I said initially, I have said also KB1 into Ka2 is equal to Kw, right? Ka2 into Kb1 is equal to Kw, right? So I gave this expression, right? Now you will be understanding the importance of this, right? So from this you can find Kb1. So how can you find Kb1? Kb1 is equal to Kw over Ka2. But Kw is equal to, at 25 degrees Celsius, it is 1 into 10 to the power minus 14, right? So 1 into 10 to the power minus 14, Ka2, how much they have given? 4.7 into 10 to the minus 12, right? So I'll be writing 1 into 10 to the minus 14 as 10 into 10 to the power minus 15, right? The reason is for the easiness of the calculation, right? So because I'll be using log, right? So this will be easy. I can avoid negative logs. So Ka2 into Kb1 is equal to Kw, Kb1 is equal to Kw over Ka2, Kw is 10 to the power minus 15, Ka2, what is Ka2? 4.7 into 10 to the power minus 11, right? So I had to find the value of this. What is the value of this? Let me use the log tables. So Log 10 is right 1.0000, right? That is log 10. What is log value of 4.7? 47 is 6721, right? 0.6721, right? So everyone know, right? If division log, if in case if you take in log, it is subtraction, right? Log subtraction. So it's gonna be 9 7 2 3, right? 0.3279, right? 9 7 2 3 0, right? Now we have to find the antilog of this. What is the antilog of this? 3279. 3279. 3279. 321 to 21 to 8, right? 21 21 to 8. I hope so. 21 to 8. Yeah, 21 to 8. That is gonna be like into 10 to the power minus 4, right? 10 to the power minus 4, right? Now I have found the kb1 value, right? So I can substitute this, right? So kb1 is like 2.128. 2.128 into 10 to the power minus 4, that is kb1. What is the concentration of OH minus? That only we have to find, right? Squared over what is the concentration of carbonate? Zero point 0.1 minus 6, right? Zero point 0.1 minus 6. Now I can make an assumption. What is the assumption? Normally we'll be making is 0 0.1 minus 6 is approximately equal to zero point 0.1. That is the assumption we are making, right? So I can write this zero point 0.1 minus x as zero point 0.1, right? Because I have assumed that x is a small value, therefore zero point 0.1 minus x is approximately equal to zero point 0.1. So from this you have to find the concentration of OH minus, right? So I'm having lack of space, I'll erase this, right? So I can find the concentration of OH minus. Concentration of OH minus is equal to 2.128 into zero point 0.1 is 2.128 into 10 to the power minus 5, right? So I'll write as 21.28 into 21.28 into 10 to the power minus 6, right? So 2.128 into zero point 0.1 is 2.128 into 10 to the power minus 5. So I can write it as 2.21.28 into 10 to the power minus 6, right? So I have to find the root value of that. That is the concentration, right? So power 10 to the power minus 6, the root value is 10 to the power minus 3, and I have to find the root value of 21.28 using log tables, right? So 21.28, the log value is 21.3263 and 3279, right? 3279. 3279. So it's gonna be 1.3279 is the log value of 21.28, right? Right. If it is a root value, I have to divide it by 2. The log value I had to divide it by 2. Then I'll be getting 0.66395, right? If I divide this by this, I'll be getting this value, right? 619. Yeah. I had to find the antilog of this. That is the OH minus concentration. What is the antilog of 66395? So 6639, right? So I can put as 6. This is 5, right? So I can put as 4039. I can round off it as 6640. So if it is 6640, 6640. So 4613. 4613. That is the concentration of OH minus, right? Now using this I can find POH. What is POH? POH is equal to negative log 10 concentration of OH minus, right? So you know the concentration of OH minus. What is the concentration of OH minus? Negative log 10 concentration of OH minus is this value, 4.163 into 10 to the power minus 3 mole dm minus 3, right? So how can you find the value? First of all, you have to write this concentration in scientific form, right? Next, what you have to do is from this 3, that is 10 to the minus 3, right? From that 3, you have to reduce the log value of 4.163, that is 0.6640, 0.6640. So you'll be getting approximately, if you reduce 0.66, 2.4, 2.34, approximately 2.34, right? 2.34, 2.43, right? So you know POH, right? Now you can find pH. How can you find pH? The famous relationship pH plus pOH is equal to pW, right? I'll erase this. What is the relationship? pH plus pOH is equal to pKW, right? So pH is equal to pKW minus pOH. That is going to be pKW, everyone knows it is 14, right? At 25 degrees Celsius it is 14. pOH is 2.34. So what is the pH? 11.66. The pH is 11.66, right? 6, 6, 7, 12, 14, right? Now the pH before the addition of H plus to the titration flask is 11.66. That is the initial pH is 11.66, right? So did you all get it? Come on guys, did you all get it? Sorry guys, there's a small mistake. The mistake is concentration of OH minus. I have found it as 4.613. I have put the concentration of OH minus as 4.163, right? So it must be 4.613, right? That is the mistake, right? Yeah, next thing is same, right? So I have used the same log value, right? So others also same. Okay, right. So you all have got it. So the next question they're asking is what is the pH at the first equivalence point, right? Now we have found the pH at initial pH we have found, right? So I'll note down the KB1 value, might be useful in the upcoming questions. I don't know, right? So I'll note it down here, right? So this is I found it, right? KB1 is equal to 2.128. So I'll write it as 2.13, right? I'll write it as 2.13 into 10 to the power minus 4, right? This value I found it, right? Okay. Now they're asking what is the pH at the first equivalence point, right? How can you find that? Now first equivalence point, who is there? Now all of the carbonate will be converted to bicarbonate, right? So that is what is happening at first equivalence point, right? So first equivalence point, what is happening? Now you all know carbonate was there at the first equivalence point. Carbonate was converted to carbonate, right? Sorry guys, there was a power cut, right? So right, we found the initial pH in the titration flask, right? And then the question was what is the pH after the first equivalence point, right? Now first equivalence point, what happens? Carbonate will be reacting with the H plus and all the carbonate will be converting to bicarbonate. That is what is happening, right? So what was the initial moles of carbonate that was present? That was 2.5, right? 2.5 into 10 to the power minus 3 moles. That was the initial moles of carbonate that was present in the titration flask, right? And then first equals point you found as 25 centimeter cube. That is, you're adding 25 centimeter cube of H plus from the burette, right? So the initial added moles, if you multiply by zero point 0.1, you'll get initial added moles is 2.5 into 10 to the minus 3 moles, right? This is the initial scenario, initial moles, right? Now the reacted moles and the final moles. Those are the three sentences we write, right? So how much is going to react? Carbonate and H plus equally they are present, right? So they are going to completely react. So 2.5, the complete moles is going to react, right? So here also 2.5 and 10 to the minus 3 is going to react. And what are they going to form? They are going to react and form the same amount of bicarbonate, right? They are going to react and form the same amount of bicarbonate. So end of the reaction will be having 0 moles of carbonate, 0 moles of H plus, and we'll be having 2.5 into 10 to the power minus 3 moles of bicarbonate, right? This is the scenario at the end of the first equivalence point, right? Now they're asking the pH at the end of the first equivalence point, right? Now who's present at the end of first equivalence point? Only bicarbonate is present, right? So this bicarbonate is gonna form a equilibrium because only it is present, so it's gonna form a equilibrium, right? So bicarbonate is gonna react with water. So physical states. So what is it gonna form? Is it gonna form carbonate or carbonic acid? So I said, right, remember it, H2CO3 is gonna form. H2CO3 is gonna form, right? And OH minus is gonna form, right? Okay. Now you had write the same three sentences. Initial concentration, I means initial concentration mole over decimeter cube. So if you write the unit itself, it's enough, right? So no need to mention as initial concentration. Write the unit here, or you can write it at the corner also, right? So initial changed concentration and the equilibrium concentration, right? So initially, what is the concentration of bicarbonate? Concentration of bicarbonate, not the moles of bicarbonate. What is the concentration of bicarbonate? So I'll find it here separately. You're having 2.5 into 10 to the power minus 3 moles of bicarbonate. That is the moles. You need the concentration. Then what you have to do? You have to divide by the volume. What is the volume? Initially 25 centimeter cube was there. You added 25 centimeter cube of H plus, and now you have how much? 50 centimeter cube. 50 centimeter cube of solution. The bicarbonate is in the 50 centimeter cube, right? Because initially 25 was there and you added 25. Total is 50, right? So constant volume is going to be 50, right? So convert into decimeter cube. I'll multiply this by 1000, right? So then I'll be getting how much? 2.5 over 50. That is 5 over 100. That is 5 into 10 to the power minus 2, right? That is the concentration of bicarbonate, right? That is the concentration of bicarbonate. Okay. So that is the initial concentration of bicarbonate, that is 5 into 10 to the power minus 2. Initial concentration of carbonic is 0, OH minus is also 0. And assume the breaking amount is Y, right? Because initially we took X, right? So here we'll take Y. So Y, Y, Y. So equilibrium will be having 5 into 10 to the power minus 2 minus Y. Here you'll be having Y, and here you'll be having Y, right? Okay. Now what you have to do? You have to write the Kb value. You have to find the concentration of OH minus POH and then pH, right? That is the normal way. Right, I'll erase this. So what is this? This is base, right? So is it gonna be KB1? No, KB2. This is KB2. This is KB2, right? So KB2 is equal to KB2. Concentration of H2CO3 aqueous, right? Concentration of OH minus over concentration of bicarbonate HCO3 minus, right? So what is not included? What is the reason? Pure liquids are not included, right? So you have to find KB2 first of all. So I'll rewrite this equation. Kb2 is equal to, now you all can see concentration of carbonic acid and concentration of hydroxide is same, right? Y. So you can write carbonate as OH minus, right? You can write the carbonate concentration is equal to OH minus. Therefore, instead of bicarbonic acid, you can write, so instead of carbonic acid, you can write the hydroxide, right? So OH minus into OH minus, I can write it as OH minus squared, right? I can write it like that. And what is the concentration of bicarbonate? 5 into 10 to the power minus 2 minus Y, right? So I can make assumption. What is the assumption? 5 into 10 to the power minus 2 minus Y is approximately equal to 5 into 10 to the power minus 2, right? Right, that is the assumption. So I'll erase the top part. Now, first of all, I have to find KB2, right? How can I find KB2? I know that Ka1 into KB2 is equal to Kw. Ka1 into KB2 is equal to Kw, right? So I can find Kb2. Kb2 is equal to Kw over Ka1. Kw is 1 into 10 to the power minus 14. So for convenience, I'll write it as 10 into 10 to the power minus 15. And what is Ka1? 4.3 into 10 to the power minus 7. 4.3 into 10 to the power minus 7, right? So using log tables, you have to solve this. So log value of 10 is 1.00. And log value of 4.3 is, so log division means log subtraction. So you had to subtract. What is the log value of 4.3? 6335. 6335. 6335, right? So if I subtract, what will I get? 5663, right? So what is the antilog of this? 3665. 3665 is gonna be 23 26. 2326. 2326 into 10 to the power minus 8. That is kb2, right? Now I know kb2, so I can find using this expression and find the OH minus, right? So kb2 is going to be 2.326, right? So I'll write it as 2.33, right? 2.33 I'll write approximately 2.33 into 10 to the power minus 8, right? 10 to the power minus 8 is equal to, what is the concentration of OH minus? That is, we have to find over 5.2, 5 into 10 to the minus 2 minus y, we approximated as 5 into 10 to the minus 2, right? So I can put here 5 into 10 to the minus 2. What is the concentration of OH minus? 2.33 into 5. What is 2.33 into 5? 2.33 into 5. 5, 1, 6, 1, 11. 11.65, right? That is 11.65. 2.33 into 5 is 11.65, and I can write it as 10 to the power minus 10, and OH minus is gonna be square root of it, right? So 10 to the power minus 10 square root is 10 to the power minus 5, right? So 11.65, I have to find the square root. How can I find it? So I'll erase this part. So using log tables, I have to find it, right? So don't use calculators when doing calculations, right? At home also use the log tables, because practice is what you're going to do in the exam, right? So you have to practice using log tables in the at home also, right? Don't be lazy and use calculators. So 11.65, the log value is going to be 1 point 11.6 is going to be 645, 645 and 5, 645 and 19, 665, 664. 1.664 is the log value of 1.0664, right? That is the log value of 11.65, and to find the square root, I had divided by 2, right? If I divide it by 2, I'll be getting 0.5332, right? So I have to find the antilog of this. What is the antilog of this? 5332. 34 1 3. 34 1 3. That is the concentration of OH minus, right? So from this I can find POH. What is POH? POH is equal to negative log 10 concentration of OH minus, and put A equals here, right? So concentration of OH minus is going to be negative log 10 3.413 into 10 to the power minus 5, right? 0.5332 mole dm minus 3. So how can I find? From 5, right? From 5 I had reduced the, from 5 I had reduced the log value of 3.413, that is 0.5332. How much is it? 3.5, 3.47, right? Approximately. So pH I know. How can I find pH? We know that pH plus pOH is equal to pKw, right? So I can find pH. pH is gonna be pKw minus pOH. How much is it? pKw we know it is as 14, right? It is 14. pKw is 14. pOH is gonna be 3.47. So it's around 11, 10.53, right? 10.53, 10.53. The pH is 10.53 at the first equivalence point. First equivalence point, the pH is going to be 10.53. Okay, understood? Understood? Right, guys, there's a small mistake. Huh? 5 minus 0.5332 is 4.47, right? 4.47. So POH is going to be 4.47. So it's going to be 9 point, right? 9.53, right? So small calculation mistakes, right? Okay. So did you all get it? Is it okay? Right. So didn't I note the initial pH? Right. Okay, this is the pH at first equivalence point, right? pH at first equivalence point. pH at first equivalence point. pH initial initial. Right. What is the pH at initial, guys? Tell me somebody. pH at first equivalence point is the 9.53. What is the pH at initial? Anyone? All right, 11.66 it's in. Right, 11.66. That is the first pH initially. Right. Now, what is the next question they ask? What is the pH at the second equivalence point? What is the pH at the second equivalence point? Now, how can you find that? Same thing. What is happening in the second equivalence point? Bicarbonate is converting to carbonic acid. That is what is happening, right? So if I take a bicarbonate, now at the end of first equivalence point, you'll be having bicarbonate, right? It's CO3 minus. At the second equivalence point, what will be happening? You will be adding more H plus, right? And you will be getting H2CO3. And put the physical states. Don't forget aqueous, aqueous, aqueous. Now, what was the initial amount of bicarbonate that was present? That was 2.5 into 10 to the power minus 3 moles, right? If you all can remember, that is the value. Initial moles, reacted moles, final moles, right? And to reach the second equivalence point, you added another 25 centimeter cube of HCl, right? What is the moles of HCl that was added after the first equivalence point? Another 25 centimeter cube was added, right? So what is the moles of added? H plus. That is zero point 0.1 into 25 over 1000, right? That is 2.5 into 10 to the power minus 3. 2.5 into 10 to the power minus 3 moles were added, right? Initially, there was no carbonic acid, right? Right. Now, completely it's going to react, right? Because both have equal moles. So, therefore, H bicarbonate is going to be completely reacting with the H plus added. So, 2.5 into 10 to the power minus 3 is going to react. So, here also 2.5 into 10 to the power minus 3 is going to react. And here 2.5 into 10 to the power minus 3 is going to form. And the end of the reaction will be having 0 moles of bicarbonate, 0 moles of H plus, and 2.5 into 10 to the power minus 3 moles of carbonic acid. Right. So at the end of the second equivalence point, you'll be having only carbonic acid in the solution. Right. You'll be having only carbonic acid in the solution. Right. Now this is the scenario at the end of the second equivalence point. Right. Now who's going to determine the pH? This carbonic acid is going to ionize. Right. This is going to ionize. So how will it ionize? Bicarbonate, right? It will be ionizing in water. And what will it form? Bicarbonate and H3O plus. That is what is going to form, right? Because H2CO3 is going to release one H plus and water is going to accept that one H plus. Okay. Now what is the initial concentration? Initial concentration, right? Not moles. So I'll find the initial concentration of carbonic separately. Now you all can see what is the moles of carbonic that is formed. 2.5 into 10 to the power minus 3 moles, right? What is the, to find the concentration, you have to divide by the volume. Now, what is the volume? Initially 25 was there, right? So second equivalence point is when you add 50 centimeter cube of H plus, right? 50 you added, 25 was there. What is the total volume? 75 centimeter cube, right? You'll get that. 25 was there. At the end of first equivalence point, you added 25. To reach the second equivalence point, you added another 25. So the total volume is going to be 75 centimeter cube, right? And to convert into decimeter cube, I'll multiply it by 1000, right? What is the concentration? 2.5 over 75, right? So I'll write it as 25 over 75 into 10 to the power minus 1. That is like 1 over 3 into 10 to the power minus 1. 1 over 3 is like 0.33, right? Into 10 to the power minus 1, right? 75 you all understood, right? So what did I do? 25 over 75 into 10 to the minus 1. 10 to the minus 3, 10 to the minus 3 got, right? 25 into 10 to the minus 1 is 2.5 divided by 75. So it's going to be 1 over 3. That is going to be 0.33, right? So the concentration of bicarbonate is going to be 0.33 into 10 to the minus 1. I write it as 3.33 into 10 to the power minus 2. Right? So there is no bicarbonate present, there is no H plus present. Right? Now what is the reactant moles? Change in concentration. We said we gave X, we said Y, now we will take this as Z. Right? Z is gonna form, Z is gonna form. So at equilibrium we'll have 3.33 into 10 to the minus 2 minus X, 3.33 into 10 to the power minus 2 minus Z. You will have be having here Z, here you will be having Z, right? This is at equilibrium situation, right? Now what you can do, you can write the K expression and then you can find the H plus concentration, right? So what is this? This is Ka1. This is Ka1, right? So Ka1 is equal to concentration of bicarbonate, concentration of H3O plus over concentration of weak acid H2CO3, right? Now what is the Ka value? No need to find, right? They have already given 4.3 into 10 to the power minus 7, right? So when writing the value for Ka, write with the units, right? 4.3 into 10 to the minus 7 mole dm minus 3. You have write that. What is the concentration of bicarbonate? Z. What is the concentration of H3O plus? Z. So both are having the same concentration. So I can write this as concentration of H3O plus squared over what is the concentration of weak acid? 3.33 into 10 to the power minus 2 minus 2 minus Z. Right? So I can make assumption. What is the assumption? 3.33 into 10 to the minus 2 minus Z is going to be approximately equal to 3.33 into 10 to the power minus 2, right? That is a approximate assumption that I'm making, right? So I'll erase this, right? So if I solve this, I can get the concentration of H3O plus. What is the concentration of H3O plus? That is going to be 4.3 into 10 to the minus 7. So this is, I can 3.33 into 10 to the minus 2 minus Z is approximately equal to 3.33, right? So I can do, so 4.3 into 3.33, right, into 10 to the power minus 9. So I have to find the root value of this. That is going to be the concentration of H3O plus, right? So 4.3 into 3.33. So using log is easier than multiplying. So if I use log, 4.3 is 6335. 0.6335 is the log value of 4.3. Log value of 3.33 is going to be mm, 5224. 5224. So as this is a multiplication, when you take the log values, it becomes as an addition, right? So 95511. So I have to find the antilog of this. What is the antilog of this? 1559. 1559. 1432. 1432. Why did I put decimal here? Because there is a 1, right? So I have to move decimal 1 place here. Into 10 to the power minus 9, whole thing square root, right? So I'll write it as 1.432, right, into 10 to the power minus 8. So then I'll get 10 to the power minus 4 into, using log values I have to find this, right? So 1.432 is this value, right? 1.432 is 1 point, sorry, 0.1559. 1559. 1432, right? 1432. 1559, right? 1559. So I had to find the I had to, this is the log value 1.59, 0.1559, 14.3, gain 2, 1559. So I had to find the, I had to take the half of it, right? Then only I can get the root. So if I take half of it, 0.07795, 0.7795, right? I can take it as 80. So what is the antilog of this? 780. Approximately 12, right? Approximately 12. That is 1.2, right? Approximately 1.2, right? So how I can find the pH using this, right? Because pH is equal to negative octane concentration of H3O plus. pH is equal to negative octane concentration of H3O plus, right? So what is the concentration of H3O plus? Negative octane 1.2 into 10 to the power minus 4 mole dm minus 3. So what is the pH? From 4 I had reduced the log value of 1.2, that is 0.0780. That is gonna be approximately 3.0. I can take it as 0.08, right? So then 3.92, 3.92, right? I can assume it as 0.08, right? I can assume like that. So if I assume like that, it's gonna be 3.92. So the pH at the second equivalence point is gonna be 3.92, right? So is it clear for you all? Is it clear? Right. Good. Right. Now final part to do is to draw the pH curve, right? We have to draw the pH curve. So I'll note this down also. pH at the second equivalence point is 3.92. Right. So how can I draw the pH curve? So the y-axis is the pH values, right? The y-axis is the pH values, and the x-axis is the volume of HCl that is added. This is the pH value, and this is the volume of HCl that is in centimeter cube, right? So the first what is the pH? Initial pH 11.66, right? Somewhere here 11.66, right? Now when you add acid, what's happening? pH is decreasing, right? So pH is gonna decrease. pH is gonna decrease, right? pH is gonna decrease, right? So this is at the first equivalence point. First equivalence point will be happening there. What will be happening? There will be a rapid pH change. There'll be a rapid pH change at equivalence point. You all know, right? When you're doing titrations also, at the equivalence point there'll be a rapid pH change. So that is the first equivalence point, right? So what is the pH around the first equivalence point? 9.53, right? 9.53. So this will be around 9.53, right? Next what will be happening? Again the you're adding acid, again the pH will be decreasing, right? So again it will be decreasing, again there will be rapid pH change, right? Again there will be rapid pH change, and then there will be only H plus. So again it will be going like this. This is the second equivalence point, right? This is the first equivalence point. First equivalence point, what is the volume? 25 centimeter cube. Second equivalence point, what is the volume? 50 centimeter cube, right? Okay. Any doubts? So this 9.53 comes around the mid, right? Again, 9.53, and 3.92 comes around the midpoint of this value, 3.92, right? Now what is the indicator you can use for the first equivalence point? I taught you, right? So first equivalence point, what is happening? Carbonate is converting to bicarbonate, right? So what is the indicator you can use? Phenolphthalein, right? You have to use the indicator phenolphthalein. Phenolphthalein. What is the indicator that is used at the second equivalence point? Methyl orange, right? Methyl orange. Methyl orange, right? Methyl orange, name orange, right? So this is the complex part of pH, carbonate acid titration. So I hope you all got it, right? If you all have any doubts, ask me, right? So I might upload to the YouTube also, right? So if YouTube, those who are watching in YouTube, if you all have any doubts, uh either comment or whatever, right? Okay. So this type of titration is the complex part. What is that? Carbonate is in the titration flask and H plus, the acid is in the burette. So the other way you can do is, that is by placing this in the opposite way. That is titration flask you are having the acid, and in the burette you are having the carbonate, right? So this is the titration flask. So I'm good at drawing, therefore I just okay. Right, titration flask you'll be having H plus, and in the burette if you keep carbonate, now what will be happening? The moment you add carbonate, right? Carbonate, now here excess H plus are present, right? So soon the carbonate will be converting to reacting with H plus, right? There are many H pluses, right? So it will be directly converting to carbonic, right? It will be directly converting to carbonic, that is carbonic acid, right? So this is the reaction that will be happening, right? So in these type of titration you'll be having only one equivalence point, right? So that is like the normal equivalence point reactions. So what happens? Carbonate will be coming at once, it will be converting to carbonic acid, right? So in this case it happens in two steps. It will be converting to carbonate will be converting to bicarbonate, and bicarbonate will be again converting to carbonic acid, right? But here at once itself it will be converting. So you have to be careful with the how it is placed in the titration flask, right? So when you are doing the question, you have to check whether is this type of titration or is this type of titration. If this type of titration comes, it's a simple scenario, right? One reaction happens, so you'll be having only one equivalence point, and you will be having only one rapid pH change in the pH curve, right? So this is like the normal titration. Yeah, they'll ask what is the pH before, right? Before the addition of pH, same thing, right? So carbonate will be there, sorry, H plus will be there, which is a strong acid, so you can find the pH, right? So if you know the concentration of H plus, you can find the pH before the addition of carbonate, right? So then if you add stoichiometrically lesser amount of carbonate, so then there also will be remaining H plus, right? So you can find that one also. um, and then at the equivalence point, carbonic will be there. So you have to using Ka values, you have to find the carbonic equivalence point, and then after the equivalence point excess carbonate will be there, and also carbonic also will be there, right? So then it will act as a buffer, and then you can do the titration. That is like the normal titration, right? So no need to worry about that, right? So this is the complex part, right? So you have to understand this carefully. So maybe I'll do a question with this type, right? This is not tested much, but still I'll do a question of this type also, right? So in the future, right? So I hope you all got this type of titrations, right? I hope you all have the idea. And this is you all have done, right? Sodium hydroxide. Now if you take titrations, this is like weak base strong acid titration, something like that, right? So same way, there is no much to explain in this, right? So this is the complex part. I hope you all understood. So if you all are having any doubts, put me a message also if you all can, right? Then we'll see you in the next class. Okay, so this is the last part of pH revision is done, right? And most probably I think we'll be doing KSP and those things in the future, right? Right. Okay, then have a nice day. We'll meet you soon. Okay.